Yeah, so I think we'll start today's session. We are mostly concentrating on the dev tools and also a bit on the IDE and how they can make the process of creating your app or debugging your app a little bit easier. So I'm just running a sample app. Also curious, what IDEs do you use?
Ile tu moja.
Sorry, I didn't quite get you.
VS Code.
Oh, VS Code. Nice. With Copilot or not in the AI train?
Na not with Copilot.
Okay. Anyone else? I've personally been a CASA person with AI. Oh yeah, I see I'm eventually on CASA. And we also have Android Studio. Anyone on Windsurf? Anyone who uses NeoVim and the like? We have Mushira who uses CASA and VS Code. Nice. So always to use Beton. So you hear my entire yeah. I think you can all see my screen. Yeah. So whenever you run an app, I think by default the widget inspector opens up. That's what appears on the right. So I'm just going to close this one and instead open the one that is on a browser, just because I think that experience is usually better. Mm. Yeah. You can see my screen. We have the DevTools that's been opened on my browser, and they relate to this running app. So the DevTools have different tabs. Oh, can see Julian uses both Android Studio and VS Code. Yeah, so that's interesting. Yeah. So yeah, the DevTools have different tabs. You have the Flutter DevTools, which just gives you information about the current DevTools thing. You have the inspector, which shows you the general widgets that are on the screen. We have the performance tab, the CPU profiler, memory, the debugger, network, logging, app size, and deep links. And also for certain tools, like if you're using provider, they'll also have their own tab over here, just because it's extensible. So you too can create your own DevTools extensions. So we'll start with the Flutter inspector. Now, the inspector gives you a snapshot of the current widgets that are on the screen. So for example, I have this screen with the Flutter DevTools demo and certain cards over here. If we look at the inspector, you can see we have the main app, which would be this widget. I can see in my run app is set to the main app. Then we have the material app, which would be here. And the material app internally has a number of widgets which have also been hidden, but they're helpful. They're the things that help with things like dialogues working, passing down the material widget to every other widget, things, yeah, such things. I think the scaffold messenger should also be part of the material app, the router that's in there. Then from here, we can see the next thing we have is the home page, which would be this widget. Now I just had one huge scaffold with an up bar and some, and we can see from here, we have the scaffold, we have the body being the list view, and we have the up bar, and it gives us all those widgets. If I was to go to a different page, say this one, then I can come and refresh here. You can see, because when you push a route, you're basically adding it to the stack. So you can see we have the home page over here, and you have the next page, the network inspector page. Both are in memory. It's just the network inspector page is above the home page. So that's how we come to this. And if I come back and refresh, we no longer have the network inspector page. Now, if I were to click on one, say this card, can see we have some information on the right side, which is the layout explorer and the widget details tree. The layout explorer is especially useful because sometimes you may wonder why something isn't sized as you'd expect, or maybe positioned where you'd expect it. Yeah, in such cases, coming to the layout explorer can help save you hours. So if I were to use an example of the column, you can see you have two rectangles drawn over here, an outer one and an inner one. The outer one tends to represent, okay, like in this case, you can see it's a paint boundary, but it's more of the parent. If I go to the demo card, we should see, okay, in our cases, it ends up being there. Yeah. If I go to the list view, you can see it's a custom multi-child layout. And you can see small differences, like the parent having the width of 411 and the height of 890. The list view having the width of 400 of 810 and a of 80. So this can really help you with debugging layouts. If I go to a column, you can see my column has the text, the size box, and another text. And we can also see the same thing here. The first text has a width of 243 and a height of 28. The size box is here with a width of 0 and a height of 8, because that was for spacing. And lastly, the last text. Also, we can see the things like the flex factor, the main axis alignment over here. All these things can be visual, so they can really help you in understanding where a layout behaves the way it does. We also have the widget details tree, which is this second tab. It now lists all the details, more in a text-based format. So you can see up here we have the card, then the inkwell, the padding, then the column. just as we have it over here, card, equal, padding column. And for the things like the column, it gives you a lot of the details of what's already been configured. So like the direction is vertical. I have, okay, the direction is more of a flex property because for will be horizontal. You have the main axis alignment, the size, the cross axis alignment, all these things it gives you one area with which you can check it out. Now, other than the layout, still within the Flutter inspector, you can see we have a lot of other options at the top. We have the slow animations, if you want to understand how an animation is happening. Let's say here we have, okay. Yeah, you can see if I click on it, there's an animation going to the second page. And if I click the back, there's a different animation to return to this page. But it might be very difficult to describe without, with it going that fast. So slow animations tends to help slightly. If you can see, you can now easily see that it's a fade in and a fade out, as well as the scale factor. That would be harder to see without the slow animations. So that's what really helps with that. We can also have the guidelines. If you've tried working with something like Figma, guidelines tend to help you know, for example, to align things, can help you to know, generally with placement of things, if something looks odd, your tiny ruler over there can help make sure things are well aligned. So that's what the guidelines do. Now, lastly, we have, next we have the baselines. This is regarding texts. So I would, yeah. Not sure if you can see for an example of this green line. It's also over here, although it might not be very clear. Generally, a baseline is, if you can remember with exercise books, how we'd have the lines and you're supposed to write on the line. So in that sense, that's similar to what a baseline will do. Sometimes you may have a row that you're trying to align items on both sides. The text might not be very well aligned, which sometimes looks weird, and the baselines would help you with that issue, at least to notice them. Now, I'm going to skip the repaints on first and go to the oversized images. So sometimes we may load really big images and Flutter would not really complain. And we have an example on this page. By the way, the entire app had been written with AI just a few minutes before the meeting. So I have an image over here. Flutter is not complaining because you can see it loads it quite well. But the actual image size is quite big. If I can check it again. Yeah, the image size is 1200 by 900 pixels. So you may wonder if Flutter is not complaining, why would an oversized image be an issue? Actually, I'm curious. What are your thoughts on the oversized images? Is it really an issue or are we prematurely optimizing? You can share within the chat, or yeah, you can also speak if you're able to. So the main issue with oversized images is memory. If you think of, say, you want to, let's say, maybe make something like a gallery app. If you're loading oversized images, you quickly would run out of memory, causing your app to crash and so on. So it doesn't exactly show up when you're testing, but that can be an issue when you come to actual user devices. So that's where this highlight oversized images comes in. What it does is it inverts the colors of images when they're oversized. So like you can see this one has been inverted because it was an oversized one. If I switch to a normal sized image, it still stays the same. Whether it's highlighted or not, it stays the same. But when I switch to oversized, it's inverted. So now that we know how we can identify the oversized images, it's not just enough to know oversized. It's important to know what we can do. Now, if we have control over the images, it doesn't affect the layout so much because you're able to specify the size of the image as you wish. Say if I decided I wanted to be a small image and put a size box. Where's my image? Just a, can see I have full control over the image. Although yeah, the layout would be affected if I was not constraining the sizes. But yeah, that is also a different issue with oversized images. Now, the things that you can do to deal with oversized images are, one, if possible, control it from the source. So let's say if you have full control of the server, you can have a smaller image set for the mobile endpoints and a larger image for more desktop focused areas. If you don't have full control, Flutter gives you an option that helps, which is for the image network property, for the image, all the image widgets, you'll see that we have a cache width property and a cache height property. So just as an example, let me use 200 and a cache height of 310. Now, a cache width and a cache height are different from the final size of the image. That's controlled by the width and height property. The cache width is at what size it would be decoded. So you make a trade-off between memory and CPU. In this case, you tend to use the CPU a little bit more. But if I did that, then did a restart. You can see the image is, I've still selected the oversized option, but we're no longer having it be flipped. It's no longer really oversized. So this can help if you notice that maybe your app has been crashing on some users because of memory issues. This can help a bit. The only thing to be careful with it is you can end up having a much lower resolution image. So use it sparingly. yeah, and that's it with the oversized images part. We also have the repaint. Now, whenever you're building the UI, you have three different phases: the build phase, the layout phase, and the paint phase. The build phase is the one that most developers interact with directly. It's when we are building the widgets. The layout phase is when they're being positioned on the screen. So passing down the constraints and getting the actual sizes. Then the paint phase is when they're being painted now, uh, giving the color, the actual appearance. Sometimes you'll notice that, let's say your app is a little bit janky. You don't get the 60 frames per second or 120 frames per second performance, even though you can't, if you try to optimize the build, it's not really getting to it. So if you're not measuring, you'll think that the problem would be on the build phase. But that's where these tools come in. So when you highlight repaints, it can show you which phase of the screen is being changed. So for example, when I switched, you can see the entire thing has been highlighted to mean the entire page repainted, as well as each of these elements. Now, most of the time, the entire screen would repaint, and that would not be an issue most of the time. You'll, however, notice for things like list views, they'll always have their own separate repaints. And that's because list views and the equivalent, the list view builders and list view separated, usually wrap the elements with a repaint boundary. So a repaint boundary is a tool that can be used if you know that a certain section of the screen will not really need to be repainted with the rest of the screen. It can be a performance optimization in certain scenarios. So let's say, for example, I had a background that's very heavy to paint, and I have a different widget that's supposed to track, let's say, the mouse movement. Say if I wanted to have a drawing app as an example, if the entire expensive background is being drawn on the movement of the mouse, the app gets quite a bit janky. So in such a situation, you can have the background have its own separate repaint boundary. But yeah, again, this is such a niche performance optimization that only go for it when you've faced the issue. Flutter is fast by default, so you would probably never really need to do that. So for the repaint boundary, one place that easily shows us that we have it is if I were to come back to the layout inspector again, click on a demo card, you would see that its parent is a repaint boundary coming from the list view. Now, you can see that list views have a property called add repaint boundaries. If I turned that to false and restarted, hmm, the screen has repainted in a different way. It's no longer separating for each item. That happens even if I go to a different screen and come back. It's no longer repainting them separately. Now, Again, I would repeat, it's such a niche optimization that I'd say stick with the Flutter defaults. So that would be it for the inspector side. Do we have any questions before we continue? Any comments? Okay, I think we'll continue then. Yeah, so I'm going to skip a whole bunch for now and go to the network tab. If you come from a web background, network would feel like home in the sense it's similar to the network that you get on a browser. I think I can even display it here. If you inspect a web page, yeah, one of the options is network. So they do the same thing as here. So from here, you're able to see all the network requests that you're making. If you'd like to, for example, debug and make sure that you're passing the authorization headers, debug the response that was coming, this would be the page to go. So I'll just clear all the previous methods and okay, that has bugged out. Oh, it's just my computer being a bit slow. So whenever we're making network requests, that should probably be a HTTP or DO request or whichever library you decide to use. Yeah, you're free for that. I'll make an example here of making a few requests to the JSON placeholder API. Yeah, and I will have all my results here, and you can see all the network requests that are made. I can come and check a GET request. You can see the overview, the headers, and the response. So for this case, it's a free API, so I do not have to have any authorization headers, but that could be debuggable from here. And for the response, you can see what I got, the user ID, the ID title, and body. So that can be helpful. While we are on network requests, just wanted to also give a small tip. If data does not depend on other data, fetching it in parallel tends to be a little bit faster and a much better experience. Here I had an example with which I can simulate a slow connection. You can check with serial what happens. As you wait, it's still loading as one comes after the one by one. Yeah, basically that. So if each request is taking a second, in this case, I'm making 5 requests, so that would take 5 seconds. That's different from parallel requests in that if each request is taking a second, I'd still wait 1 second because they're all started at the same time. So here's an example of it. And we get all 5 at the same time. Or an error occurs. Yeah, we get all of them at the same time. So the question would be, how do we do the fast request versus the parallel request versus the serial requests? For the parallel requests, it will take as long as the slowest request. In that, if the first takes 1 second, the second takes 2 seconds, the third take, and the rest take 1 second, it will take as long as the 2 seconds. So just to show that, Flutter do asynchronous requests in parallel. An example here, or what I'm basically doing was creating 5 features. And then we have this method called the feature.wait. So feature.wait and still brings back the result as a list. Or if one item fails, it'll stop there. So yeah, this can really help make your user experience a lot better. So now that we're done with the network, I'll just go a little bit quickly through the remaining ones. Unless we have any comment or question. Yeah, in a sense, it's concurrency. Thanks, Mushira. Yeah, so we'll go to the other. So we have the performance tab. As you can see, I have a very performant app over here. So when you want to make your app fast, the worst thing that you can do is go on guesswork. So the first step to performance is always measuring. You might find that the thing that makes your app slow is very different from what you think makes your app slow. That's one. Two, when it also comes to performance, Flutter is fast by default. So most of the time you might really need to tweak things. There is the saying that premature optimization is the root of all evil. You don't want to do unnecessary work in the mind of making an app faster. Three, most performance improvements would be gained from architectural changes. An example is we just had a look at the network and making asynchronous requests. It does not matter if I make my app, the widgets build in 2 milliseconds instead of the 8 milliseconds or so, if I'm still going to wait for an entire minute for a network request to occur. The bigger gain be obtained in, let's say, introducing a cache to help reduce the amount of time waiting for the network. That being said, when you come to the performance tab, if you really want to measure your app performance, you would not do it in debug mode. Right now, I just have debug just to show the layout, but debug mode tends to add a lot of things that make it possible to debug, but slow down your app. And that's why you also have the warning over here. You're running your app in debug mode. Debug is not indicative of release performance. So most of the time, you'd probably want to do in profile mode or release mode. So that being said, we have a graph that comes as the first thing. The graph has two different bars. The first one represents the UI, and the second represents the raster. The UI is normally something that you have a lot more control over. So it's probably the widgets and how they're building. The raster tends to be more towards the GPU. So that tends to be like images, or if you have any shader thing, that go more towards the raster layer. In general, you have your target, which is usually low. So when the graph is in blue, you've built the widgets within the allocated time, which is normally 8 milliseconds if you're targeting 120 frames per second, or 16 milliseconds if you're targeting 60. The ones that are in red are the ones that have gone over budget and are probably the ones to cause junk. So I'll just click on one frame as an example. The UI might be slightly different. I'm on an older version of the DevTools, but yeah, on clicking it, you can see that we have certain details that pop up at the bottom. And over here, we can see it has details on both the UI phase and the raster phase. Yeah, 16 milliseconds should be 60 frames per second. That's right, Jill. So, yeah, you can see in the UI phase, I took 10 milliseconds to build the widgets. Then we have the layer phase, which took 0.2, and the paint phase 0.6. So if you go in the profile mode, this would really mean that wrong in the widgets that I would need to look at. The raster in this case was really fast because it took 1.9 milliseconds. If I go to a different frame, say this one, you can see we had the build take 800 milliseconds, which is a crazy amount of time. But this happened because of what we call shader compilation junk. It's not something to worry about so much because Impeller is part of why the Flutter team really wanted to invest in Impeller is to try and solve the shader compilation junk. Without Impeller, the option would be to compile your shaders. That's an option that I can go to do. It's not very difficult. It's not very necessary now to Impeller. Now, at it this way, we don't have a lot of inputs add-on. So there are extra things we can do. If I come to the top, we have this enhanced tracking option, which you can track the widget builds, the layouts, the paints, also do platform channels, but I'm not really using any platform channel in this app. So once that, I'll just clear these ones and do something else in the app. Like maybe switch this and check. You can see that paint took the longest time. You have the different phases and we can track the build counts. Yeah. Now, tracking the build count can be and have a widget being built more than is necessary. So if we come to this tracking section, you can see, for example, my card widget was built 5 times in the network inspector page, and it gives me details of all the different widgets. So if I had something that was like in the 300 area, I'd be concerned and try to check what's happening. Now, we also have this rebuild stats, which shows us the same thing. Then we have the timeline events, which is now more helpful for determining what exactly was happening. So we can use it to really find out the slower widgets. So when you come to the timeline stats, let's say I pick from this time. Oops, sorry. Yeah, for this particular event, you can see the build took a really long time, and you can see what was being built. We had main app, then you had material app, then the different pages and so on. So if something was taking a little bit too long, this is where we can come to check. And we also have more information over here about what took how much time. So that can be helpful to try and find out the slow parts. I'll just keep this. Next, we have the CPU profiler. Now, sometimes you may want to know what our app is doing. Let me just record here for a minute, do something, and stop recording. So the CPU profile would show you which functions are happening within your app and how much time they're taking. And right now, fetching the samples is taking longer than the amount of coding. It can be have a say you have something that's taking too long and you don't really know how much time it was taking, and you can now use that to narrow your search. Yeah, we now have it here. So you can see we have different things. You have the bottom-up view, the call tree, method table, and the flame chart. And for each, you have the total time, the self time, and the method. Total time is the time overall spent on a function. A lot of them would be Flutter functions. But if I had a very slow function being called, it would really shine over here. Is that within one function, not looking at the other functions that it calls. And then over here, we have the exact method that's calling, as well as the path to it. Let me see. Yeah. We have the call tree, which shows you how you're calling the different functions. Have the method table, which isn't so different, but clicking on one, you'll be able to see more details about it. And you have the flame chart, which also shows you how much time was taken for each of the different functions and the specific order. Now, I'm going to quickly skip through the memory. Memory just helps you know what's taking a lot of memory, and also quickly spot, say, in case you have a memory leak. A memory leak is when something is not really getting disposed, so ends up taking more memory over time. If you had memory leaks are really hard to spot because they tend to be really slow. If we had a particularly bad example, you'd see this blue line going up with time as more and more objects get allocated. Now, this app doesn't really have so many classes, so you won't really be able to see it over here. But when you have your own objects, let's say the controllers or maybe the data that you have within your app, and you've used classes to show them, they'd pop up here and you'd be able to see what's taking how much memory. You can see, for example, I'm taking 34 MB of memory with the app. Total size with 34.8. Because I don't really have many dependencies, it's still at 0. Yeah, more or less. For the debugger, it's similar to the IDE debugger in that you can set up breakpoints. You have your call stack that will show the functions that were stopped at a breakpoint, the variables that were available, and a list of all the breakpoints. And we also have the logging, which is a lot of the time just what's being printed, or if you're using a logger, yeah, what the logger is logging. You'll be able to see all the details here, the time, the site, the source. So like for one of them are Flutter navigation other than the HTTP, and actually what you had passed in to be printed. Now, for app size requires you to use this to find out what's making an app quite big. So sometimes it can be the assets, sometimes it can be maybe a certain package or whatever. App size would help you find that. And for the deep links would just help you bag deep links within your app. Yeah, that would be it for the DevTools tour. Uh, any questions, comments? Okay, kuna salamu hapo kwa comment section. But yeah, also just curious. Hoping, does anyone know what a deep link is? Anyone? Mm. Oh yeah, I'm asking, what is a deep link?
Um, Hi everybody. If I could answer what a deep link is, according to the docs, it's the links that not only open an app but also take the user to a specific location deep inside the app. For example, a deep link from an advertisement for a pair of sneakers might open a shopping app and display the products page for those particular shoes.
Yep, that's exactly it. So yeah, they're a feature that most apps would need. You'd probably need it at one point or another. Just the ability to be able to link to a specific page from an external link. Yeah, so that would be it for today. Thank you all for coming. If you have any topic ideas, feel free to mention them within the group. I'll see you next Wednesday.
Bye guys.